Students and learners. So, I am Neha Sharma, Assistant Professor at Engineering College, Halawad. So, we were discussing about the etching process and we discussed in detail about your wet etching. And then uh, today's class, we will be discussing about your dry etching. So, basically before going to dry etching, let me discuss you the problems that we face with wet etching. So, wet etching is generally used for large pattern sizes, generally larger than 2 micrometers. Then we go for wet etching process. It is an isotropic process. That means it is in all directions, sloped side walls rather than straight walls kind of structure we get with this wet etching. And wet etch has to be combined with subsequent rinse and dry step. This increases the chances of defects or contamination. Of course, because we are handling like very strong chemicals, so contamination problem can be there if it is not rinsed and dried properly. So, and of course, if we are handling these chemicals, they are actually hazardous in nature. As you talk about hydrofluoric acid, very strong acids we are using here, nitric acid, HNO3. So, they are very hazardous, and so safe disposal of these chemicals after the etching process has been completed. So, such sort of safety issues are one of the problem. And undercutting and resist peel off can happen if time is not controlled or etch condition change during the process. Like if temperature changes, temperature is like very low or very high, then undercutting and resist peel can happen. Resist peel means when very strong etchant solution you have taken and it has excessively removed your the layer, and along with that your resist has also removed. So, we discussed this resist peel in our previous lecture. So, now dry etching. So, in dry etching basically 3 types we are using, like reactive ion etching, plasma etching and ion beam milling. So, in this dry etching basically the etchants are in gaseous phase. So, etchant gases are the primary medium for the removal of your material. So, there is no chemical, like literally liquid chemical is not there in dry etching process. So, first we will be going to discuss about your plasma etching. Before moving on to plasma etching, let's discuss what is a plasma. So, plasma is fourth state of matter, like after solid, liquid and gases, we have fourth one as plasma. So, how does we can form plasma? So, when your third state like gas, if you keep on heating your gas, so like I can say you have a solid and you start heating solid, it will convert to liquid, or when you start heating more this liquid, you will get gas. And then also gas को भी अगर हम लोग बहुत high temperature provide करते जाएंगे, then क्या होंगे उसके अंदर जो molecules है, it will break up. मॉलिक्यूल्स टूट के आयंस में कन्वर्ट हो जाएंगे, तो आपको पॉजिटिव और नेगेटिव आयंस मिल जाएंगे, वो फ्री हो जाएंगे. और जो फ्री आयंस उस गैसेस एनवायरनमेंट में जो रहेंगी उसको हम बोल रहे हैं प्लाज्मा स्टेट. सो बेसिकली इट इज़ एन आयोनाइज्ड गैस, द गैस विद हैविंग आयंस. So, because of this it can conduct your electricity just because it has free electrons in it. तो वो इजीली मूव करेंगे, इट कैन कंडक्ट इलेक्ट्रिसिटी एंड कैन इवन प्रोड्यूस मैग्नेटिक फील्ड, बिकॉज मैग्नेटिक फील्ड मूविंग इलेक्ट्रॉन से क्रिएट होता है और उसके अंदर हमारे पास पॉजिटिव एंड नेगेटिव आयंस मिल रहे हैं हमको. सो ईजिली इट कैन कंडक्ट इलेक्ट्रिसिटी एंड योर मैग्नेटिक फील्ड. ठीक है, अब इलेक्ट्रिसिटी ओनली गैस वी नो इट्स अ बैड कंडक्टर ऑफ इलेक्ट्रिसिटी. तो दिस इज़ द डिफरेंस बिटवीन योर प्लाज्मा एंड योर गैस. आई होप दिस थिंग इज़ क्लियर. दैट मीन्स heat gas at very high temperature or at very high potential, then you will get plasma. Okay, so coming on to plasma etching. So in plasma etching the chemical etchant is introduced in the gas phase, and for example I have given here for silicon oxide CF4 tetrafluoromethane is used, and this gas is first evacuated, the chamber is first evacuated before introducing the gas, so that no contamination and no other particle has been there. उसको फुल्ली इवैक्यूएट करा जाता है. उसके बाद CF4 जो हमारी एक्चुअल में एचेंट गैस है, उसको हम लोग इंट्रोड्यूस कराएंगे. एंड RF frequency electrodes are used to generate the plasma that ionizes the gas. So these electrodes actually will provide a very high potential to this gas, and it will break into positive and negative ions and finalized plasma. In plasma generation and recombination it is taking place एक साथ होता रहेगा. Generation भी होगा and recombination, but after some time we get a stable plasma state where you have all आयंस प्रेजेंट इन इट. तो उसको हम लोग स्टेबलाइज्ड प्लाज्मा बोलते हैं. उसके बाद ही दिस एचिंग प्रोसेस विल स्टार्ट. So ionized gas attacks the oxide layer and it removes it. So basically what is happening, gases are transported to the wafer surface, where they adsorb to the surface and react with the wafer surface material at the step edges. The gases then deabsorb from the surface and then it will be removed. So these are the 5 steps given in this diagram here. The first one being the generation of your etchant species, second one being the diffusion to the surface, third one being the adsorption towards the surface, the fourth one being the reaction, and the fifth one being deabsorption and diffusion into the bulk of gases, which is basically the removal of your undesired layer. जो पार्ट हमको नहीं चाहिए, जो पार्ट बेसिकली हमको एच करना है, उसका फाइनल रिमूविंग. सो क्या इसमें हाई पेनिट्रेशन हो रहा है. ये पेनिट्रेशन जाके जो हमारे प्लाज्मा स्टेट हैं, प्लाज्मा जो आयंस है वो जाके उससे रिएक्ट कर रहे हैं एंड देन इट इज़ रिमूविंग द लेयर बेसिकली. ओके, मूविंग ऑन टू द नेक्स्ट. This is you can see the plasma chamber here. Here from one end your reactive gases has been introduced, and you can see the RF electrodes are in parallel. So RF on one side your wafers are placed, and your so after introducing this reactive gas, this RF electrodes basically provide very high potential and convert it into plasma, and then slowly it is coming and reacting with your wafer. So this is the diagram of your planar plasma etch configuration. So the wafers are held on the ground chuck close to the RF electrodes, and reactive gas introduced in the chamber is ionized, and the ions help in material removal. So this is basically your plasma etching. Next, in tomorrow's lecture, we are going to discuss about your ion beam milling and reactive ion etching. Basically, reactive ion etching is one of the very RIE chamber that we say generally, RIE chamber. So when you go to the manufacturing units, all these etchings are like in very very big chambers. You can just operate it from outside, like what's happening through commands you give, like when your wafers are to be introduced and how much potential you should give for plasma, and everything is done in a very closed and evacuated chamber. You can just see it from outside and regulate through computer. That's it. So this is basic idea. In the next lecture we'll be discussing about much of this. Thank you very much.